exploration. For 30 years, the shuttle has risen into the sky. As spectacular and familiar as a sunrise, its achievements can be taken for granted. With every liftoff of the dreams of exploration, and for the people who work on the shuttle, the pride of accomplishment. What does it take to get a shuttle to fly? For 3 decades, shuttle launches involved the entire nation, with parts coming from more than 37 states around the country. Not a product of NASA, but a product of America, with human hands putting loving care into each and every component.
Well, getting a shuttle ready to fly is a tremendous effort by thousands and thousands and thousands of people. The external tank arrives by barge at the turn basin. So that comes on a barge from Louisiana. And the solid rocket booster segments come to us on rail from Utah. And so they all come together. We stack the boosters, then we attach the external tank, and then the orbiter gets attached to the tank, and we roll out.
A shuttle launch, it's the icing on the cake for all the work that they've done. The launch team includes folks that worked on the hardware or the software months before in a building that in the middle of the night that may not have any windows in it. They know that you don't have to have a highly visible job to be important in this business.
So on behalf of the KC processing and launch teams, wish you good luck, Godspeed, and we'll see you back here just after Thanksgiving. Well, a launch here is very, very special. I haven't seen one from outside for over 10 years. I'm always in the control room. But thousands and thousands of people come to Titusville and Cocoa Beach and Cape Canaveral to see a launch. You watch the tourists, come here special. The kids, just in awe when the orbiter lifts off. It's a tremendous feeling of accomplishment. And to think that we're doing it on behalf of the country and now with the International Space Station on behalf of all the international partners, it's a tremendous feeling.
Only ice you'll ever get in Florida.
Shuttle launch is quite an experience. You need to wake up, put on your fancy clothes. You have a breakfast together before you put the fancy clothes on because you don't want to get them dirty. So you have your breakfast and you put your fancy clothes on and everything, put on your space suit, and you walk out into the Astro van. They drive you out there and you get in the launch pad.
Leading up to the launch, it's a lot of training, and it's something you've been preparing for really kind of all of your life if you think about it, because this whole aspiration of being able to go into space is something that starts pretty early on for most people. Even though you're exhaustively trained for it, nothing really prepares you for what you're actually going to feel, because there's no way to really simulate that. So it really is, on-the-job training, as the as the saying goes.
The launch is a pretty incredible experience, and I've heard a lot of people attempt to describe what it feels like. I've heard people say, oh, it's like getting hit in the back of your chair with the baseball bat. It's nothing like that. It's very hard to describe, in fact, because you're going from not moving at all to 26 times the speed of sound in only 8 minutes. And so the tremendous sense of acceleration is not one that you can really prepare for unless you've done it before.
And then at 6 seconds, the main engines light, and you feel that, and the shuttle pitches and then kind of comes back upright at 0 in the countdown, and then the solids light, and then there's no doubt you're moving.
And I remember looking over and seeing on the display, yep, all those main engines are 100%, and then it was like boom, and we were kicked off the pad.
And within a couple seconds, the thought went through my mind was, man, we're like far away from home. Already, you knew you were going someplace far away.
And as we go, then we separate from the solid rocket booster, and then the ride becomes very smooth. There's no shaking much anymore, but we are outside the atmosphere of the Earth, and we can accelerate real fast now. We have to reach 25 times the speed of sound. So as we accelerate, we start feeling the G acceleration and being pushed back on our seats. And the next 5 minutes, we're under 3G, which means 3 times our weight.
And that seemed a little bit more than 3Gs I've pulled in other situations. And I think, again, it's just because of the excitement of this being a real flight. And I felt like I was fighting much harder to get breath. And it's over about a minute and a half time frame, and then all of a sudden it's off of you. And you're like, wow, things are floating up, and we're really here, you know, this is really where we wanted to be.
Dottie, how do you like space?
I love space. I still feel like I'm
better and better.
I feel like I'm hanging upside down, but I guess I'm not.
There was this quarter of a second transition into real heavy to, whoops, floating. And that's when you have to adapt to weightlessness. It's a great ride. It's a great ride.
Before the space shuttle, spacecraft like this Apollo capsule are built for no more than 3 astronauts. Landing in the ocean and recovered by aircraft carriers, the space capsule and the 360-foot rocket that launched it are never used again. When the shuttle rolls out of the factory in the 1970s, it is obvious that America has taken a huge leap in spacecraft design. The largest, fastest winged hypersonic craft in history, the shuttle lands on a runway and can be refitted to fly again and again. It can hold up to 7 astronauts, and its payload bay can haul cargo to and from space. Space flight and how we conduct it changes radically with the shuttle concept.
But you can imagine the early spacecraft, barely the size of a desk for 1 or 2 astronauts. Now the spacecraft is the size of an airliner, and it has thousands of components and miles of wiring, and we were making the transition from the era of wires and switches and meters to digital and computers.
The shuttle's flexible design means it can carry out a variety of missions not possible before, including scientific and astronomical missions. NASA needs a new breed of astronauts, not just flyers, but scientists, engineers, doctors, and other disciplines. A whole new world of opportunity opens up for astronaut candidates who may not have applied to NASA before the shuttle. In addition, a space program actively recruits women and minority astronauts for the first time. One of the earliest uses of the shuttle is for space lab missions. For the first time, an entire laboratory, the size of a school bus, can be hauled into space in the shuttle payload bay and returned to Earth. Built by the European Space Agency, Space Lab is a prime example of early international cooperation in space. The shuttle missions allow scientists and researchers from around the globe to participate in the high-flying experiments. But why conduct science in space?
By going into space, it allows us to be able to study everything that we can think of without the presence of gravity. And if you think about it, everything that we've done in the laboratories here on Earth, all the science that we have had the presence of gravity. And so this is a very, very unique opportunity that we have so we can find out just how gravity affects all different kinds of systems.
Shuttle science missions also study the Earth itself, aiming instruments located in the shuttle payload bay to monitor the Earth's ozone layer. The shuttle also launches satellites to further observe the Earth's atmosphere. Over time, the data gives researchers important information about our changing planet. The shuttle also orbits the Earth with a series of radar mapping missions, allowing us to view the features of our world with a new level of detail. Shuttle missions also allow students to participate in science. 2 programs, KidSat and EarthCam, allow students to make Earth observations using a remote-controlled camera on the shuttle. For the first time, students take an active role in a space mission.
My name is Ebony Miranda. We want to know if you can start the car on top of the track.
Okay, let's try the top.
Astronauts also take advantage of space to partake in educational events with students from around the world. In the microgravity of space, experiments are filmed and distributed to schools for further learning opportunities. The shuttle is not only a science vessel. Commercial clients from around the world take advantage of the shuttle's capability to carry satellites into space.
Yes, it proves the physics of frisbees works up here as well as it does on the ground.
Space hardware of all shapes and sizes launches from the shuttle payload bay.
And you'd point the orbiter in the right direction and spin these babies up and eject them out, and then about half a rev later, those motors would burn, and the thing was pointed in the right direction to take it on its way to the final orbit. A great capability that the orbiter provided.
Before the shuttle, if a satellite malfunctioned in space, it became multi-million-dollar space junk. The shuttle gives ailing satellites a second chance, offering rescue and repair missions.
All got a good grip? Yes, sir. Houston, I think we got a satellite.
The shuttle scenario of having people and a work platform in space benefits all types of space hardware. But one repair job stands out above the rest: a space telescope named Hubble. Launched in 1990, Hubble is to float high above the haze of Earth's atmosphere, free to view the cosmos with unprecedented clarity. But when scientists get the first pictures back, the results are less than spectacular. Hubble has a flaw in its primary mirror, resulting in fuzzy imagery. NASA mounts a repair mission to try and salvage the telescope. Using the shuttle payload bay as a work platform, astronauts conduct a series of spacewalks to fix the telescope. The shuttle releases the Hubble once again. Scientists soon discover the mission is a success. Hubble's vision is restored, and the space telescope begins rewriting astronomy books with every new stunning image.
I think the public had not a terrific view into what the universe is like until we had the Hubble Space Telescope. As a result, people associate those images with the beauty of the universe, the numbers and the answers we get about the universe beginning with a Big Bang, and the age and chemical elements being built in stars, turning into planets, solar systems. All of that information mixed in with these beautiful pictures has allowed Hubble to actually be an icon for science and an icon for the answer to fundamental questions.
In 30 years of flying in the treacherous environment of space, the shuttle is not without tragedy. The loss of 2 space shuttles, Challenger in 1986 and Columbia in 2003, claims the lives of 14 astronauts. The nation mourns the crews as friends, neighbors, colleagues, and as the heroes they are. For some, the tragic events are a source of inspiration.
When I was in high school, I was probably in the 10th grade, I think, when we had the Challenger accident. And that was sort of the first thing from the space program that really sort of made it onto my radar screen as a big event. And it seems like a strange thing to say, well, that inspired me. But at the same time, it was something that it made me aware of the shuttle program. It made me aware of how important this work was that the shuttle program was doing. and that people were willing to risk their lives for it. So that was sort of the big event to me that put it onto the map and made me think about, well, what would a career with NASA be like?
For Columbia, which was lost in its return to Earth, the public becomes directly involved with the recovery of the spacecraft. Recovery teams, many of them volunteers, diligently search for debris, hoping to help NASA discover how the accident happened. The public outpouring of grief was matched only by the drive to continue. NASA and the nation were determined to make the shuttle better and safer, and to persist. The shuttle was grounded for years following each accident. As it rose again each time, the pride in America and its space program was palpable.
You know, you hear in tragedies that they say, well, they died doing what they loved to do, and they would have wanted us to carry on. And that is absolutely 100% true in the Columbia case. I know every one of those astronauts personally, and I know each one of them would have been extremely disappointed had the program ended because of that tragedy. They truly, truly believed in what they did. They gave their lives for what they did, what they believed in. So we had to find the problem, fix it, and fly again. And on launch day, we were doing just that. It's what we do. We are launching America's space shuttle for the good of the country and the good of the world. It's what we do. We have to do this. A lot of thoughts back to Rick and his crew. But it was also looking forward.
The Mir space station. For years, the Russians had pursued living and working in space with long-term missions. The space station Mir is their latest achievement. For shorter missions, America develops the ultimate spacecraft with the shuttle. What would happen if the two space programs worked together? The United States and Russia, long rivals on Earth and in space, embark on a program of unprecedented cooperation called the Shuttle-Mir program.
We had these very different programs, and we saw that they were complementary. Even the water that we dump overboard from the fuel cells on the shuttle could be drank on the space station. They fit together beautifully.
The Russian outpost is serviced by the American shuttle, which brings supplies, hardware, and people. U.S. and Russian astronauts conduct spacewalks together, and American scientists live on board Mir for months at a time, conducting research.
I found it very, very interesting to live and to work on the Mir space station. A lot of times people will say, well, of the flights that you've had, what is your favorite flight? Of course, you can't pick out a favorite flight because, you know, you enjoyed every single one that you did. But if I could only choose one and I was limited to just one, I would have picked the Mir flight that I was on. And the reason why was because it gave me the opportunity to be in space for a long period of time.
The program is not without challenges. A fire breaks out on the Mir, but the crew manages to save the outpost. On a later mission, an unmanned supply ship collides with Mir, depressurizing one of the modules and tumbling the station out of control. Once again, the crew works together to keep Mir flying. Through the dangers and hardships, there are many lessons learned.
Perhaps the most important element of that program, beyond the physical engineering accomplishment, which was substantial, was, I'll say it in Russian first, Взаимного доверия и уважения, the mutual trust and respect. It turns out that these complex programs that we undertake, you can't put them in place by signing a law or a bill and saying it will be done. That doesn't make it happen. It happens one-on-one, person to person, with mutual trust and respect. That's what we achieved in the Mir program, along with the very products and engineering achievements.
From the beginning, it is imagined that the shuttle can build a space station. Yet for the first 20 years, the shuttle is never used for this purpose. This changes in the late 1990s. Building on the success of the Shuttle Mir program, the United States partners with Russia and other countries to build an international space station. The station is so large, it must be sent into orbit one module at a time for assembly. Russia sends up the first component, Zarya. The first U.S. module, Unity, is loaded onto the Shuttle Endeavour. This new international era in space starts with a bit of magic.
There's a picture Red Huber took. It was a rainbow over Endeavour sitting out on the pad. And I have to share a little private story. My daughter and I are real Wizard of Oz aficionados. We launch, you know, then that night everything went absolutely perfect. We're on orbit, and the wake-up music for our first day on orbit was Judy Garland singing Somewhere Over the Rainbow. And man, it brought tears to my eyes. And I always tell folks, somewhere over the rainbow, dreams come true, because we launched over that rainbow that night, and that was a dream flight, and everything went absolutely perfect.
Two station components, built in two different countries, meet for the first time in space. The shuttle robot arm does the heavy lifting, and a series of spacewalks finishes the job of connecting them together.
I was fortunate enough to be assigned to the very first assembly flight, which was a tremendous feeling for me to be in at the very ground floor and basically laying the cornerstones of the International Space Station.
Over many missions, piece by piece, the shuttle brings up station components. More laboratories, solar arrays, and segments of the enormous station truss, the backbone of the station. The station becomes the largest spacecraft ever built.
The station was humongous. The size of 2 football fields, 8 habitable modules, 6 people permanently inhabiting. It was a living laboratory that we walked in with people inside, with life, with stuff everywhere. It was humongous compared to what it seemed before.
As a final mission for the space shuttle, building the International Space Station may be the most lasting achievement.
So the space station would never have been possible without the space shuttle. It's a phenomenal accomplishment when you consider not just the engineering of it. I mean, here's hardware from around the world that comes together in space, is put together and works for the first time. But the cultural differences between, you know, Japan, ESA and all its partners, the United States, Canada, Russia, and we're all working together as one. And that is really a fantastic model and a great model for the future when we eventually explore beyond our home planet.
For the thousands coming to view the launch, the troubles began early this morning. The roads leading to the Space Center were jammed hours before the scheduled liftoff.
These people were here because they believe in the shuttle, and they wanted to show it.
History is being made. I want to be right there. Right. Well, they're being made.
Well, I'd like to be an astronaut, but, you know, it takes a lot of courage, and I'd be scared to go up there right now.
I've seen more launches than anybody else here, and everyone is just as exciting, but this means more to me than any other, I think.
What does it mean to me? A whole opening up of a new world.
I definitely think since the shuttle was invented, they thought it was like a revolutionary thing, and it's definitely helped us to build ISS, and I'm kind of sad to see that they're retiring it. I mean, I always loved to watch on TV when they first started, when they shot them in the air. I've always been fascinated with rockets, but shuttles, they just really astound me.
I believe that the Space Shuttle program is one of the most significant engineering feats that the United States has ever been involved in. And the opportunity to go to the launch site and at KSC and see a launch is the most memorable experience I've ever had. It is an awesome, awesome experience.
When you explore, you're always looking forward. You're always looking at what's next instead of just where you've been. What the shuttle brought, I always felt that Apollo lacked was a sense of science fiction to it. Here's a spaceship that you can fly and land, and there was something very romantic about landing a ship rather than parachuting down into the water, and I think that captivated people.
I think it's meant a great deal to America. It allows us to be some of the first people to explore the world and to be the leaders to tell the rest of the world about what's going on in outer space and to let us know that it's bigger than just us.
I think it was like a great experience, and we got to explore, a lot out of space and about what we don't know. So I think it was really good.
It's been a new frontier for America. It's been a chance for us to continue kind of the American dream of reaching into new lands, and it's given us hope of being able to continue spreading out through the universe.
I would like to see if we could maybe explore one of the gas giants.
I would like to go to Mars.
Neptune. I want to go to Mars. I want to journey to Mercury. Mars.
I want to orbit the Earth.
This is Mission Control Houston, and again we have joined the International Space Station Flight Control Room here at the Johnson Space Center in Houston. And you were watching one of the a tribute to the Space Shuttle. That was space.